So once again, welcome all the participants for this faculty development program for advanced computing AI, data science and generative AI for research and education. So today onwards will be start and 27 it's going to be finished. So the session handler will be the Dr. Srinivas Naresh sir, professor. So first topic is considered for preserving techniques in machine learning, foundations and methods. So next second topic become like application privacy. I'm aware of machine learning in healthcare, finance, so electric vehicles, and so further like it may be time will be there means so depends upon that we are trying to give our hands-on session. So first thing up to 7:30 the session will be continued. After 7:30 to 7:45 the small break. So at the time please take over your whatever it is like home dinner or something like that. So 7:45 it will be start for second session. Can go for depends upon the convenience based. So please be I'm expecting your cooperation as well as much more support to you. Keep update if any doubt will be there mean we are going to be given best efforts. So this is the thing.
बोल तो रहा है
मीटिंग दादा मीटिंग ओपन करो.
Yes, ma'am.
So let's start the session. So before that, I'm going to be given that one of the initial intimation of that AI tool. Only the purpose of usage of reading. Those who are need to go for that further thing. So first name is called, everybody's are known, maximum all the people are known. So scholarly. So this is a AI power summarizer for research paper is going to be extracting what are the highlights and key findings and references. So structured summary as well as and quick absorbing and grasping long academic articles. So that is going to be used for that scholarly article. So that AI tool is going to be given that. So please be keep update. So these AI tool, what the purpose is going to be asked then in after a session completion, the small MCQ. It may be useful for you. So, and next, size summary. So, is going to be used for summarize the scientific articles, and AI convert to complex research into like digestible summaries. So, the maximum summaries are, it won't be like what I am saying. We cannot believe, right? So, there is no validation content. So, based upon that, maybe is going to be get much more insight. Next, so pedal AI. This is also only for the user purpose. Next, the impact is focused on simplifying academic content. Next, converting the research paper into simplified summaries, often highlighting the key points and arguments and finding something other than that. Next is like,
hello. Yeah, Setu sir.
yes, sir.
Yes, sir joined.
Yes, sir. Yes, sir.
Yeah.
Take a snap. So you can share your PPT. Start it, sir.
Yes. Is it visible?
Yes, sir. Clearly visible, sir. Yes, sir.
Fine. I'll start my session.
Yes, sir. Yes, sir. Thank
Sorry
you, sir.
for little delay, some technical problem. Good evening, all. Good evening, all. We'll start the session now. You all know we'll have two sessions today. So now it was 6:30 odd, so that from 6:30 to 7:30 we'll have privacy preserving techniques in machine learning. That are foundations and methods. See, this is a wonderful area we can work with, because you may be a research scholar, you may be a PhD scholar, or you may be a BTech student. Anyone can do work on this, because this is a novel area.
Sir, just a minute, sir.
Hello.
All the participants, please be mute on you. Please be mute yourself. After that, we can go for further things. So please be, this is biggest request.
So in this session, first we'll see privacy preserving techniques in machine learning, that are foundations and methods. So after that, we'll go in the next session, we'll see applications of privacy preserving integration to machine learning for various healthcare and energy applications. We'll see. So first, let us have why privacy preserving machine learning. You all know about machine learning, because that is a buzzword and the world is revolving towards AI and machine learning, mainly machine learning. Why? Because it is a decision support system. So it will give decision, so that it has gone that much importance. Let us see if you take in healthcare applications, let us see, we'll take some classification. That means whether a person is having a chance of getting heart
Sir,
disease.
sorry for the disturbance. Kindly please make a present yourself only. Is going to be up only for downloads that file only. Please be make it get visibility.
Hello, sir, is it screen visible?
Screen visible, sir, but not yet open. Document not yet opened.
Document not opened. Okay, 1 minute. Now see, sir.
Yes, sir. Visible, sir.
Hmm?
Yes, sir. Fine, sir. Visible.
Okay. See. So first we have to see whatever you study. First we have to see the reason behind the study. What is the motivation behind this privacy preserving? See, let us take some healthcare application like some heart disease. Whether a person is going to get a heart disease or not. That is the classification. That is the binary classification. Let us assume. So for that, we should have a training data set, and we have to train on the data set to get a model that can classify whether a person is going to have heart disease or not. Fine. But what is happening here is we want to give this healthcare data set to a third party, that is cloud. There the model will be built. So if a cloud, if the cloud sees the sensitive data of healthcare information of a specific person, it is dangerous. Why? Because if a person is having a engaged person is there, if somebody notices that he is having some health issues, he won't get married. So that we have to protect privacy of a person in view of healthcare, because in medical records we'll have various health data will be there. Let us assume his BP, his sugar levels, and his family history, or he's having any previous negatives in health. So if somebody finds that, they can, so that is a great loss to a person privacy. So that the privacy preserving integration to machine learning is highly needed. Privacy preserving machine learning integration is highly needed. Privacy preserving machine learning integration is highly needed. So that we are going to focus on this in this session. So, and let us assume a financial data. Let us see whether you are going to take a loan, to get a loan or not. So that is the binary classification. A bank has to decide whether to give a loan or not. That is a binary classification. There also we'll have data set, and the data set should be given to cloud. The data set should be given to cloud for building a model that can predict whether the loan has to be sanctioned or not. So that is a binary classification. There also, if a person's data is disclosed by the cloud, then he may not get a loan, because if they're having higher loans, so that the bank won't give that loan to them. And not only this bank, by seeing his financial record, no one give loan to him. So that privacy is needed in certain areas like healthcare and finance mainly. After that, in the next session, I will focus on energy also. Why privacy is needed in energy systems also we'll discuss. So see, exploration of sensitive data in domains like healthcare and finance and energy. Traditional machine learning requires centralized data collection. That means we are giving entire data to a centralized cloud, so that the data may be opened and data may be disclosed. That may be a great loss in view of privacy. So our intention is to build privacy preserving machine learning systems to protect the privacy of an individual in view of healthcare or finance or anything, wherever it is needed. See, here two things are there. One is we have to predict something that may be heart disease or whether to give a loan or not. But at the same time, we have to provide privacy. So instead of one task in machine learning, we are having two tasks here. One is privacy and other is utility. Utility means we need certain accuracy. Well, the system should work with higher accuracy and precision, so on, so that we have to build a better system. And at the same time, we are integrating privacy to that, so that we have to balance privacy and also the decision support system that can give accuracy. So we have to balance utility and privacy. That utility is nothing but finding predictions, and privacy is nothing but we have to keep the sensitive data secure. Have to see privacy, so that we have to build various systems that can provide privacy. So those are the systems, so privacy preserving machine learning systems we have to see in this session. See how to get privacy, how to give privacy. Is it audible? Hello? Hello?
You can go, sir. No problem. Yes.
Fine. So how to integrate privacy to machine learning systems? So see, we are having various options. One is homomorphic encryption, and two is differential privacy, and third is secure multi-party computation. We have to see one by one after other. See here, see, first we look into homomorphic encryption. Why? Because homomorphic encryption is very much important here to deal with privacy. See this diagram. Here it is very clear that here one client is there. Instead of sending the data directly, he will send the data encrypting with his public key to a cloud to build a machine learning model. So that machine learning model will be built. After that, the model is also encrypted model will be done. And after that encrypted model, after decrypting, we have to get the result directly. See, I'll explain very clearly. What I'll do is, actually in machine learning, what we'll do is we'll give data set directly to the cloud. But here we will give the data set to the cloud by encrypting it. That means the cloud cannot see the data. I'll explain with a simple example. What is homomorphic encryption? I will give an example. See, here I want to add 3 and 5. I will give a simple example. I want to add 3 and 5, but I will give this task to the cloud, So cloud has to add 3 and 5 here. So, but cloud should not see 3 and 5. That is my intention objective here. So I want to provide privacy to this 3 and 5. So what I will do is I'll encrypt 3, E of 3 plus E of 5. E of 3 and E of 5 is given to cloud. But cloud knows how to add that. But homomorphic encryption property is nothing but E of x plus E of y is equal to E of x plus y. Because we'll encrypt 3 with client's public key, so that it is encrypted with client public key, and E of 3 is sent to cloud, as well as E of 5 is also sent to cloud. There, the cloud will add these two, so that E of 3 plus E of 5 with the property, it can become E of 3 plus 5. So what we'll get? E of 8. So the cloud cannot see 3 or 5. Even the result also. Result is of the form E of 8. So that E of 8 is given to client and he can only open it because it was encrypted with his public key, so that it has to be opened with his private key only. So that 3 plus 5, 8 can be seen by client by decrypting it with his private key. So that here we are providing output privacy, the result privacy, and also we are providing privacy to encrypted data also. Encrypted that is testing data. That means we are giving 3 and 5 by encrypting those. So they should not be disclosed. But the result is also not open to anybody. It should be open to only client. So that is the logic behind homomorphic encryption. And the next thing is differential privacy. I won't much stress upon this differential privacy. Differential privacy is nothing but adding some noise. And we have to make the input data, that is training data, is not visible to others. So that is about differential privacy. And you can see here another logic is also there in for anonymity. At the olden days, what happened is, one day they have taken some training data set in which the first attribute is name, and they felt that if you close name, the remaining data, whatever data is there, no problem. They felt like that because if Naresh is there and Naresh healthcare data, BP, sugar and family history is there, but if you remove name of Naresh, then nobody knows that data is with Naresh, it belongs to Naresh or not. Nobody knows. So there is no problem. They felt like that. But what happens is somebody integrated this training data with other data set. Then location and address will be there. That will be matched, and we can find the person's name also, so that anonymity fails. So it is not the solution. Closing no name itself is not a solution for providing anonymity. That means for providing privacy to the data without disclosing the name of the person. So that is not a solution. Then all these techniques come into place. Here, see, first database, see here, database without A's data. Suppose Naresh data. Database without Naresh data is the first database. Second is database with A's data, Naresh data. So we are given data without Naresh to a model, to build a model. So some analysis has been done. So then we'll get some outcome. With Naresh, without Naresh data, we got some result. And with Naresh data also, we got the result. But the result is very much closer. So that if you leave one person's data, there is no issue. In that case, we can make it randomly. Let us assume some election is done. In the first database, 1,000 people are there. In the second database, 1,001 is there. So in 1,000 has been given for counting. 1,000 voting has been given for counting. Then it is 510 and 490. So that 510 and 490. So that 510 is the winner, 490 is the loser. Fine. And if you drop one person's data, Naresh data, then the data is 499 only. But in that 499, we have 999. In that 999, only previously 510 is there, now is 59. So there is no loss. 59 and 499 like that. So that if you drop one person's data also, there is no issue. That is called data privacy. So in a similar fashion, if you can remove certain people data, there is no loss of privacy. So in that case, this data privacy will protect privacy of individuals. In that case, they will tell. Fine. Next, secure multi-party computation. What do you mean by secure multi-party computation? This is a wonderful technique. Wonderful technique. Let us, I'll give a wonderful example to you all. Let us take here, without knowing other person's data, a group of people want to compute something. A group of people want to compute something. So that computation should be done, but individual data should not be opened. That is called secure multi-party computation. Multi means more than two. Let us assume, I'll explain this with an example. See, the problem here is, let us take ISTS College Institute, in which there may be 200 faculty or 300 faculty. I want to find average salary of a faculty. But here the condition is individual faculty's salary should not be disclosed. That is the issue here. So that is also privacy. I'll explain with three people here. So let us see here three faculty here. First is $100. First person's salary is $100. Second person's salary is $200. And third person's salary is $300. So in the first person, what he will do is, instead of, now the cloud has to compute the average of these three salaries. If they have given directly 100, 200, 300, then cloud can see that A salary is 100, B salary is 200, C salary is 300. But our issue here is, we don't want to disclose individual salary, so that A will split his 100 into three parts, and A will kept 50, and 30 has been given to B, and 20 has been given to C. In a similar fashion, B has taken 80 and given 100 to A, has made it 80 minus 80, 100 to B, and 180. So if you make total, that is 200 only. As C, C salary is 300. It will give 0 to A and 350 to B, and C is minus 50. C is minus 50. So that the total is 300 here. But B doesn't know what is the salary of A. C doesn't know what is the salary of A. B doesn't know what is the salary of A and C. So each other doesn't know the salary of the other people. See, so now this, after this, see here, instead of computing 100 plus 200 plus 300 by 3, what they will do is, A will add 50 minus 80, 0. That is minus 30. Minus 30. Instead of sending 100, he will send minus 30 to cloud. After that, B will send 30, 100 and 50, his shares. So that is 480. And C will send 20, 180 and minus 50. Here that is 150. So now these three values will be sent to cloud, so that cloud should not know what is the salary of A or B or C, because that is minus 30, 480, 50. See, 480 minus 30 is 450. 450 plus 150 is again 600. So 600 by 3, that is 200. So without noticing the individual values, the cloud can find the average salary. So this is a wonderful technique. We can apply in machine learning, or we can apply in neural network. So that is a wonderful technique we'll have, and we can get wonderful research papers out of this. And we are also working on this. Already we submitted a paper on this based on multi-party computation. We have done some federated learning techniques. So see, now I want to explain homomorphic encryption in detail to you all to get good hold on that. So see, homomorphic encryption is nothing but, instead of building a model directly on data, it will be done on encrypted data. That is, instead of making it on plain text, it will be done on ciphertext, so that it should not be opened, it should not be disclosed to anybody. So that is nothing but homomorphic encryption. So there are various types of homomorphic encryption is there. So in which the timelines are like this. It was initially invented in 2009. After that, various versions comes into place, 10, 10, 11 and 12. So see, I will explain homomorphic encryption with a wonderful analogy here. See, here the problem is LIS workers need to assemble raw material into jewelry, but LIS is worried about theft. So LIS is the owner of the shop and he want to build some jewelry, but that has to be made by the people working in his shop. But he has a doubt that they may theft something. So that how it will be done without thefting anything, the jewelry outcome should be done. So this is like homomorphic encryption. I will show analogy on this. So these are all raw material. These are all raw material. He is the worker and this is LIS. See, LIS puts material into locked glove. Actually, LIS put material into locked glove box. So there is a glove in it and it will be locked and all the material will be there in that box only. So who locked it? LIS locked it so that it should not be opened by anybody. But a worker can put his hand in the glove and he can make the item. But he cannot open the lock and he cannot find he cannot get the raw material out of it. So finally, after completing the jewelry, only LIS can decrypt it and he can open it and he will take it. So that is the thing here. So LIS puts material into locked glove box for which only she has the key. So workers assemble the jewelry. So by putting hand on that in glove which is locked, and they will make jewelry there. Workers assemble jewelry in the box and LIS unlocks the box to get the result. So that is the analogy behind the homomorphic encryption. See here, what is encrypted? So putting the things inside the box, that is called encryption. Putting all the raw material inside the box, that is called encryption. Decrypt, what do you mean by that? Anyone can do this. Imagine mail drop like that. Decrypt, taking things out of the box, only LIS can do it with required key. And evaluate, that is called machine learning model. So that should be done by whom? That should be done by workers. That their model will be built by cloud, that is third party. So similarly, worker is nothing but cloud. We have appointed a cloud for service provider for computing all these things. So evaluation should be done there, but they should not see the internal things. That means here that is jewelry, there here that is raw material, there that is data set or sensitive data. So that is the wonderful analogy we are having with homomorphic encryption. Why homomorphic encryption? So because we have to work on ciphertext instead of plain text, so that confidentiality problems won't come because data won't be opened. Second, ability to compute our ciphertext instead of plain text. That's I already told. And one cloud use information without knowing the content of that information. So cloud will do some computation, but they doesn't know what is internally there. So privacy is guaranteed. So that is the advantage with homomorphic encryption. I already explained that. So let us take 5 and 6. I want to multiply 5 and 6. So what is 5 into 6? You all know that is 30. So for that, I won't send 5 directly. So CT of 5, that means crypto magic, something, some that is some encryption. And CT of 6. So CT of 5 into 6 will be done. CT of 30 will be there. CT will be opened by only the person who is having that key, So that is about this. That is called homomorphic encryption. So we are having two types of homomorphic encryption. One is partial homomorphic encryption, other is full homomorphic encryption. The difference is in partial homomorphic encryption, we can work with only addition. That is E of x plus E of y is equal to E of x plus y. But it should not work with encryption. That is, sorry, with multiplication. That is E of x into y is equal to E of x into E of y. That should not work. But in full homomorphic encryption, it will work. So there are certain examples you can see, that is RSA or something you can use for encryptions. Fine. So advantage is cloud security. Cloud security will be there. So in cloud, there is no issue of making the data out or disclosed, because they are all in encrypted form. Working information stored in database, queries to search engine. So after building a model, we can find some queries and we can get result for some other new data also. So these are all advantages of this. So we can solve various problems with this: wireless sensors, mesh networks, and problem related to personal records like medical records. So I already told we can have issue with healthcare records. So analyzing disease. So while analyzing disease, we have to give our data openly to the cloud so that there is a problem, so that we'll encrypt the data and we'll send to the cloud. So that is, I already told, fully homomorphic encryption is there, and partial homomorphic encryption is also there. Partial is nothing but it should work on only additions. But fully homomorphism will work on addition as well as multiplication. See, I will see various versions of homomorphic encryption here in different forms. See here, a fully homomorphic encryption scheme supports addition and multiplication. I already explained on ciphertext. Let us assume that was invented in 2009. Let us assume some M1 is there. M1 is encrypted with fully homomorphic encryption. So we'll get C1. And another thing, M2 is encrypted with homomorphic encryption. So that we'll get C2. So now what we'll do, instead of adding M1 plus M2, we'll add C1 plus C2. So C1 plus C2 is nothing but C dash. In a similar manner, we can multiply C1 and C2 also, because this is fully homomorphic encryption. So that is C double dash. So that after finding C1 plus C2, it should be gone to client, and there he will decrypt. So after decrypting it, they can get the result, that is M1 plus M2. There you'll get the result M1 into M2 also. That is about homomorphic encryption. Here you can see very clearly. Here we can see one is generic deployment model, that is here client is here, and other is client is here, and AWS cloud is there. So see, first the client generates some key. See, that is small k with homomorphic encryption. So after encrypting x with k, what he will get? Though I have denoted that as closed box. See, closed box is nothing but encrypted data. Closed box. So actually, machine learning or evolution model is nothing but F. Evolution model or machine learning is nothing but F. Actually, we will get x to F. So that f of x is the decision directly. F of x is the decision directly. F of x is the decision directly. But here, instead of giving x directly, we'll encrypt x and we'll give closed box of x. Closed box of x is nothing but that is encrypted x. That encrypted x is given to f. So that this encrypted x is given on f, so that we'll get, see here, that is wonderful property here for homomorphic encryption. That is encryption of f of x is nothing but f of encryption of x. So see, we want to apply f on encrypted of x and f of e of x. F of e of x is nothing but e of f of x. That is, encrypted f of x is nothing but result. Encryption of f of x. So result is also in closed box. See, if you give closed box to f, it will close entire result. That is closed box of f of x. That closed box will be opened by only client because he knows only key. So that he can open with the key and he'll get the f of x. So that he will get the decision directly. Is it clear? I will explain again. Actually, f is nothing but machine learning model. Actually, we'll give x to f. We'll give x to f. Then f of x is nothing but decision. That's we have to know. But here we have to keep x private and f of x is also private. So we want to provide privacy to input as well as output, decision also. So that we will encrypt x. And instead of giving x to f, we will give encrypted x, that is box of x. Box of x is given to f. Then what happened is box of f of x will be output. Box of f of x will be the output. That is encrypted result, because closed box can be opened by client only because he is closed it, so that he can open this box with key, so that he will get f of x. So that f of x is nothing but result. Fine. Is it clear? So that is nothing but homomorphic encryption. And now I'll explain certain application of it. Let us say logistic regression. You all know about logistic regression. So logistic regression is a machine learning model. So there we can apply, actually we'll apply logistic regression on a given data, but instead of applying on data, we'll apply on encrypted data. That is nothing but ciphertext, so that we'll get the result also in the encrypted form. Actually, let us assume the case is binary application. So in binary application, we'll have 1 or 0. And if you apply logistic regression on encrypted data set, that is E of D, that is f of E of D is nothing but E of f of D. F of D is nothing but either 0 or 1. Either 0 or 1 is also should not be disclosed. So it is in encrypted form, so that we can provide here input data privacy as well as output data privacy. Fine. Next, the results is also like this. You all know about logistic regression. Here we'll have a sigmoid function, sigma of x equal to 1 by 1 plus e power x. So that can approximate the prediction, so that we, instead of giving x, we'll give e of x and we'll get the encrypted results. So we can apply for xg boost also, privacy preserving xg boost results also we can make. So we can apply for logistic regression, homomorphic encryption, or we can apply it for xg boost also. xg boost is an ensemble learning model. You all know. Actually, I want to show another version of this. The small x is at client side, so that should be given to server x, that is cloud. So then x is evaluated by f of x, so that we'll get f of x. But instead of giving x, we'll give encrypted x. So encrypted x can be given to f. Then we'll get encrypted result, encrypted of f of x. So I'll show here very clearly. So here x is given, x is encrypted. X is encrypted means ENC of x. So instead of giving x directly, this is evolution model or machine learning model, so that we have to give En of x to evolution model. En of x is nothing but, then if you apply f of x, we will have ENC of f of x will come. If you decrypt this, we'll get f of x. That means we'll get decision. Actually, we'll do it directly. actually in machine learning, we'll give x to f of f, so that we'll get f of x decision. But instead of giving x, we'll give here encryption of x. So encryption of x is given to f. Encryption of x is given to f. So ENC f of x will be outcome of that, and we can decrypt this so that we'll get f of x. That is called addition. That is called addition. See, we can have addition as well as multiplication. We can do this homomorphic encryption. Already I told we can deal it with addition as well as multiplication. But if you deal with only partial homomorphic encryption, it will deal with only addition only. It should not be done on. It should not be done on multiplication. So in fully homomorphic only it will be done. So actually training is performed in non-encrypted data, but performed over encrypted data in privacy preserving machine learning. So we'll have three operations here. One is addition, and other is multiplication, and third is table lookup. So where we'll do, actually, if you take linear systems like logistic regression, but if you take neural network, there we'll have some non-linear things. There we have to compute much things. So instead of addition and multiplication for non-linear linearities like activation functions and compressions, we have to take a lookup table, so that we have three operations here. And see, this is fully homomorphic encryption and machine learning, so that instead of giving x1, x2, xn directly, we'll encrypt x1, x2, xn, and then we'll give it to f, like neural network here. Then finally we'll get output y1, y2, ym in an encrypted fashion. Fine. So till now we have discussed how homomorphic encryption can be applied in machine learning. Now we have to see federated learning using homomorphic encryption. What do you mean by federated learning? First, we have to discuss that. Actually, you know about federated learning. So what is federated learning? Instead of working with only one client, we will work collaboratively. Federated learning enables collaborative model training without sharing raw data. I'll explain simple example I will give. The problem here is to find out age range of cancer patients. So for that, if you work on care data set, suppose care hospital is there is data with cancer patients. There in the data set, somebody may have cancer, somebody may not have cancer. In that, some age attribute is also there. In that age, we have to pick the people who are having cancers. So let us assume let us assume 50 to 60 years in care. So that is called direct prediction. That is, by analyzing data of care, we can predict 50 to 60. The people are getting cancer at the age in between ranging 15 to 60. That's we can say. But if you want to do it better, then we have to do it collaboratively. Instead of only care, we will take other also. Let us take NIMS or Apollo. In NIMS, it is 50 to 60 year. They're 45 to 55, and another in the third is 60 to 65. Then these three parameters age range. We won't give entire data of patient. So federated learning also gives privacy. So instead of giving entire data, only we will give the range of age. So first, second, third. So what we will do here is we will take average. First, average A1, B1, A2, B2, A3, B3. This will be sent to cloud. There what they will find is A1 plus A2 plus A3 by 3, B1 plus B2 plus B3 by 3. That is called Fed average. So the range now is instead of A1, B1, instead of A2, B2, A3, B3, we'll have A1 plus A2 plus A3 by 3, B1 plus B2 plus B3 by 3. That may be somewhat better than these because we are taking experiences of 3 hospitals instead of 1, so that we'll get better results. And again, the updates will be sent to models, client models, and again the client will retrain that, and again they will send the updates to global model. This will be done until convergence will be done. That means until the model perfectly works, it will be done. So that is the thing we are having. So that is federated learning. Is it clear? That is called federated learning. Let us take, we will assess a student performance in not only in one subject. We are taking the average of all the subjects. In a similar manner, federated learning is also not considering only one client. It will consider more clients, and taking the average of them, it will finally give the global model. So that can predict better than the individual client models. That is the beauty of federated learning. You all work in, you will have a better chance of working in federated learning because we can have great opportunity in federated learning to publish in SCI journals. See, so here another thing. Instead of giving, I'll give an example here. Let us see. What do you mean by model? I want to explain. Everyone are speaking machine learning, model, training, everything the people are speaking. But we have to know simple basics of it. Let us assume, I'll explain. The first client data is 13579 dash 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 so on. So this data is given to cloud. This data is given to cloud. Then cloud has to build a model. What is that model? Anybody? Anybody, can you tell? 13579 so on has been given to cloud. Then what is the model we are having? That is nothing but y equal to 2x plus 1. Y equal to 2x plus 1. Let us assume put x equal to 0, we will get 1. X equal to 1, 2 plus 1, 3. X equal to 3, 2 into 3, 6 plus 1, 7. 4, 8 plus 1, 9. So entire data we can predict. So that is called model. That is as simple as model is nothing but that much simple. So we'll have only linear data here. I want to explain what is model. So model is nothing but only 2 and 1. 2 and 1 are parameters there. 2 and 1 are parameters there. Another, I am taking another client. Here the data is 2, 4, 6, 8, so on. So what is the model? What is the model for client, for this client? What is the model for this client? Can you explain? That is y equal to 2x plus 0. 2x plus 0. What are the parameters here? 2, 0. Here the parameters are 2, 0. So now I want to build a collaborated model with only 2. I want to explain simply. So what is the collaborated model I want to get? That is nothing but that is also y equal to ax plus b. What is a, what is b here? Here the first parameters are 2 and 1. Here parameters are 2, 0. 2, 1, 2, 0. So now these two will be sent to cloud. Their global model will be built with 2 plus 2, 1, 2, 1, 2, 0. So 2 plus 2 by 2, 1 plus 0 by 2. 2 plus 2 by 2 is 4 by 2, that is 2. And another is 1 plus 0 by 2, that is 1 by 2. So the model is y equal to 2x plus half. 2x plus half. That is called the global model. That is the beauty of federated learning. So now the model parameters are 2, half with Fed average. We are dealing with Fed average. Fine. Is it clear? Fine. And so here we are not giving entire 13579 to global model. Only client will train this 13579 so that it will get y equal to 2x plus 1. So 2 comma 1 parameters. In second, 2 comma 0, 2 comma 0. So they are not giving entire data. They are giving only parameters. So privacy is there. So some federated learning can provide privacy, somewhat privacy. But you may have a doubt. Sir, if this 2 and 1 and 2 and 0 are disclosed in between, because we are sending the data, if somebody attacked that and if somebody got the data, they can find the average and they can build the global model. We may have a doubt. Yes, that is 100% correct. So that what we have to do is, instead of sending 2 comma 1, we'll send E of 2, E of 1. We'll send E of 2 comma E of 0. So that I already explained homomorphic. What is homomorphic encryption? There we'll have E of 2 plus 2 by 2 and E of 2 plus 0 by 2. So E of 2 plus 2 by 2, that is E of 2. E of 2 plus 0 by 2, 1 plus 0 by 2, that is E of half. So E of 2 and E of half is again given to, that won't be seen by global cloud also. It will be given to clients. Then client can open that and they can see it is 2 comma half. So the global model can reach the client. So that this is the thing we are with federated learning. So federated learning architectures. 1 minute wait. So now it becomes 7:30. I'll close at 7:30. Again, we'll start at 7:50 or 8 after your lunch, dinner. See, so in federated learning, we have seen here. So in the federated learning architecture, there we have clients and server is also there. Actually, initially the model was initialized. I will stop within 5 minutes. Model initialized. After that, local training will be done. Already I explained how local training will be done. After that, updates, encrypted updates. Instead of sending updates directly, we can send encrypted updates to the cloud. Their aggregation will be done. That is, fed average will be done, and final result will be decrypted. So that is about federated learning architecture. So here, this is a wonderful chance for you to build a wonderful application on healthcare, on finance, or electrical vehicles using federated learning with HE. So I already explained about homomorphic encryption. There is no need. See here, 3 clients are there. 3 clients are there. A cloud is here. So W1 is parameter with first client. W2 is parameter with second client. Wn is parameter with n client. These all parameters will be sent to globally. There, the global model will be built like that. And W dash, that is called average, average or something. That is again sent to here. And this will be iteratively done until convergence will be done. That means until a wonderful global model will be built, which can give higher accuracy. So, see, why use HE in federated learning? I already explained. Because if the parameters are leaked, then somebody can build a model by taking the averages. But it should not be open, so that we are encrypted with homomorphic encryption. So that is about this federated learning. Already you know, first client encrypts local gradients. Gradients is nothing but parameters. And encrypted update is sent to aggregator, that is cloud. Aggregator performs computation on ciphertext instead of direct text. So global model will be built, updated, and sent back encrypted. So client decrypt and apply updates. So this will be done until convergence will be done. Example use cases, you can apply this federated learning in healthcare, or finance, or in smart grid, or IoT. So the only challenges is encrypting the things will take much more time. So that is the computation problems are there. We can deal with this by by doing some optimization techniques, we can have these encryption times will be reduced and we can get wonderful systems. So this will have one, and for this I will have wonderful libraries because anybody can do it very easily. See, for homomorphic encryption, we are having Microsoft Seal and HElib and TenSeal is also very famous. And FL platforms are TensorFlow or Wisecraft or Flower architecture we can take, and we can do wonderful papers out of this. So the thing here is, while building a research paper, the novelty is important rather than its implementation. Anybody can do an implementation because there are many codes and people are using chat gpt, no issue with that. So if you have wonderful ideas, it can build code and uh, we can make it in a wonderful fashion, and we can build uh, quality SCI publications. So I am giving wonderful area to you all to work with. So in that there are two parts. One is privacy and other is what? Prediction or classification. We want to integrate these two. So that is the essence of this session. In the next session, we'll see various applications of the homomorphic encryption in healthcare, in finance, and mainly focusing on electrical vehicle. Because if you want to publish in a quality journal, we have to see for a great application that should be novel. It should not be done by any other people, because healthcare for healthcare many people are working on it, and many people implemented privacy in healthcare. So that we have to choose a better area that can give wonderful outcomes for us. Thank you one and all for patient listening for this session. Next session will start at nearly 8. Okay, after your dinner we'll start.
Yes, sir. Thank you, sir. So thank you very much, all the participants. So kindly please make hold. It may be due to some technical problem. So after that 100 participants it unable to do. So definitely next session won't be happen. So it will be rectified as well as so. So we will meet in after 15 minutes. Thank you, sir.
Okay.
We will just stay.
So all the participants, please be there. You can leave it after 15 minutes. It will be continued. Sir, we can start, sir. Naresh, sir, we can start, sir. No problem. It will be update you.
Now, hello, sir.
Yes, sir.
Yes, yes. Now it is fine.
Thank you, sir. Thank you, sir.
Okay. Good evening, all. Welcome to the next session. Sir, is it visible?
Yes, sir. Visible, sir. Visible, sir. Yes, sir.
Applications, privacy aware ML in healthcare, finance, and electrical vehicles. So, see, already we discussed this. Why privacy preserving machine learning? I already explained. So, we need privacy in three applications. One is healthcare, and other is finance. Let us assume healthcare. Let us take sensitive healthcare records. Leakage can harm patients. And I already explained, if a person who has not get married will have a problem for getting married if he's known, if his health problems are out disclosed. So the sensitive data should be protected in healthcare application. That is the first thing. Second, credit history, like that if you are having lot of loans, if that is known to other people, they never give credit. The other people won't give credit because you are having lot of loans. So that the finance is also needed. Privacy preserving is needed in finance sector also. Let us take my invention, and I have wonderful papers, research papers. nearly 6 to 8 papers are there in energy. So why you are having some surprise that why privacy is needed in energy? I'll explain. So we are having nowadays. So while selecting an area, broad area, we have to select an area that is highly needful, and it should impact the society. Let us assume privacy present machine learning for sustainable electrical vehicle state of health prediction, because nowadays electrical vehicles are trending. Electrical vehicles are highly trending, so that we have to, and the electrical vehicle performance is based on battery health. If battery health is not good, it won't work well. So that the now the discussion is on privacy preserving machine learning for sustainable electrical vehicle battery state of health prediction. Sustainable electrical vehicle battery state of health prediction. So what do you mean by SOH? SOH is nothing but state of health. So state of health prediction. Okay. See, motivation. So electrical vehicles are crucial for sustainable transportation. You all know. But accurate battery SOH prediction is key for performance and longevity. You all know, because mainly electrical vehicle is based on battery. Okay, as diesel vehicles are based on fuel, like that, this is based on battery. So battery will have, as human will have health index, in a similar manner for battery also state of health will be there. So our assumption, our aim here is to find state of health prediction. So we have to find state of health for a battery. State of health for a battery is a key performance and longevity. And second is data sensitivity, driving patterns, locations, battery usage that should not be known to other people. I'll explain why. So objective of study is, there are two parts. One is privacy preserving techniques for SOH prediction. SOH means state of health of battery. So exploring data processing, feature engineering, and real-time applications we have to see here. So propose a privacy preserving system model that is helpful to electrical vehicles. See here. Identified scenarios requiring privacy in electrical vehicle SOH prediction. So now, I already explained various scenarios in healthcare, because if a person's health data is out, he may not get married. So there are various issues, scenarios I already explained. But why privacy is needed in state of health? I'll explain. So the first contribution we are going to make here is why privacy is needed for electrical vehicle state of health prediction. That's I am going to discuss here. And after that, explore machine learning models suitable for SOH prediction. We have to find some machine learning models, and after that, we have to integrate the privacy preserving technique like homomorphic encryption to these machine learning models. And we have to address all those things. So see, this is wonderful area we can work with. So electrical vehicle, we are having three perspectives here. User perspective. Let us assume you have an electrical vehicle, and if your state of health, your battery health is known to other person. If somebody wants to attack you, if they know state of health of your battery, then if your battery is down, then they can expect that you can go to a nearby charge station. So for that, we have to find some path, and because the battery is very low, we will go nearby charging station so that they can attack you in the path. We are going to reach the charge station. So that is one advantage while providing privacy for state of health. If your battery health is not known to other people, they may not know your path towards charging station. So that is the first dimension or first scenario for state of health. And second is in view of user. So let us take this state of health prediction. What are the entities in it? One is electrical vehicle user, that is electrical vehicle owner, and second is service provider, so the charging station provider. So and third is company where the cars were manufactured, that is called company. So see here, for in view of service provider perspective, so competitive risks, intellectual property theft, competitive risks, intellectual property theft is there. Let us see, if some company is going to build a new car and they are working on state of health of a battery, and they found some data sets and some data, if that data is leaked, and if somebody knows this battery is working very fine, state of health is wonderful, then they may copy this principle and they can build another model. So we need privacy here also in the service provider or company view. And if a company's battery state of health is degrading and it is not at all good, and nobody will buy it, nobody will willing to buy it. So there are disadvantages if SOH is disclosed, state of health is disclosed. So that type of scenarios you have to define before going to new area. Then only we will get good quality publications. So if you talk about privacy in healthcare, we'll have very less chance. If you talk about privacy, in finance, there also somewhat lesser chance, because many people worked in healthcare after that finance, but nobody worked in electrical vehicle. But I am the first person to work in state of health prediction, where I argued that say privacy is needed for SOH prediction, and I have defined various scenarios for that also. See, so here we already discussed about homomorphic encryption. Now we can apply this homomorphic encryption for this state of health prediction. See here, in state of health prediction, we are having entities. See here, one is electrical vehicle user and other is cloud, and here EV charge service provider. Actually, EV charge service provider will collect the data from battery collection from various users, and he will build a data set. But because privacy is needed, they won't give the data set directly to the cloud. They will encrypt the data set and give it to the cloud. Then cloud will build a encrypted model. I already explained. Encrypted model will be with EV charger. If any new user will give data, and this EV charge service provider will test, and it will predict. It will predict. Fine. Next, one is the entity series. One is EV user, and other is EV service provider, and other is cloud service provider. Cloud service provider. Secure data collection and processing with encrypted computations ensure confidentiality. As I already told, secure data collection. First, we have to collect the data securely. After that, it has to be given in encrypted form rather than directly to the cloud. So that using a homomorphic encryption, will encrypt the data set and will give it to the cloud. Then cloud will build an encrypted model and given to EV service provider. So then they can predict for the new things. So I already explained homomorphic encryption are two types. One is partial and other is fully homomorphic encryption. In partial homomorphic encryption, we will have only additions. It will support only additions. It won't support multiplication. So that we have to use fully homomorphic encryption only. We have to use fully homomorphic encryption only. See, I have given a wonderful design, deep neural network. So here we are having two goals or two targets. One is prediction and other is one is prediction and other is security. One is prediction and other is security. So privacy. So one is prediction. For prediction, I am using deep neural network design. And for security, I am encrypting the given data set. I am encrypting the given data set. So that's I am going to deal here. I'll show here. This is a wonderful architecture of neural network. Here I can explain. See, in machine learning, we will have nearly mainly two phases. One is training phase and other is inference or testing phase. Inference phase. So in training phase, what we are having training data set. So training data set to provide privacy to training data set. Let us take the training data set maybe with hospital or maybe with bank or maybe with charging service provider in these three applications. So they have to provide privacy to that so that they will encrypt the data set so that it should not be open to cloud or any other people. So that is called training data privacy. That is called training data privacy. So after giving this encrypted model to what? Cloud, then cloud will build encrypted model. That means weights are all are of the form encrypted form. So that we'll have encrypted model. So that we'll provide model privacy. It should not be open. It should not be open. So model privacy is there. So after that model privacy, after building the model, we have to give the input. So input is also given in encrypted form so that we'll get the output without decrypting it. We'll find the result. So the result is also given in the form of encrypted form so that output should not known to the other people except the client so that he can only open. So output privacy is also there. So that if you talk machine learning like this with privacy, you will have better chance to publish in quality journals. See, everyone speaks about training phase, testing phase, but nobody will speak about training data privacy, model privacy, testing data privacy, and output privacy. Let us, I'll give some scenario here or some example, some instance. Let us take State Bank of India. State Bank of India build a model on their training data set. If that model is open to some ICICI bank, if they can use, what is the use of building a model for SBI? So SBI should have a model that should be private. That is called model privacy. That model coefficients or weight should not be directly known to other banks. So that is called model privacy. If SBI builds the model, he is the owner of that model. No other member cannot open it, should not open it. So that privacy will be provided to the model. That is called model privacy. So we are having 4 types of privacy. One is training data privacy, and second is input data privacy, and third is model privacy, and fourth is output privacy. So we will do this in this four fashion. See here, training data privacy. So I have given, I have divided the proposal framework into 2 parts. One is training phase and other is testing phase. See here, one, data collection will be done by service provider company. Data collection is here. After that, they will encrypt the data set with service provider public key, and that has been given to cloud. A cloud will build a model here on encrypted data set. After building a model on encrypted data set, it should be encrypted result coefficients. So that is called as encrypted model. encrypted model. Encrypted coefficient means encrypted model. So encrypted model is with service provider. Encrypted model is with service provider. So service provider then use inference phase. So after that, a new user data has to be given to this model in encrypted form. After that, this model will give a result, encrypted result. So that encrypted result will be decrypted by the service provider, so that we'll get the result. We'll get the result. So that is called as testing phase for data privacy. Here already I explained, first we are encrypting training data so that we are providing training data privacy. And after giving encrypted data set to the cloud, and cloud will build a encrypted model. Cloud will build a encrypted model. So that encrypted model will be given to service provider. That encrypted model will be given to service provider, and he can use that encrypted model to find predict after given that to this will predict a encrypted result. Encrypted result will be decrypted using client's public key. So client public key will open, so that the data results will be known to client. Is it clear? So that here we are providing training data privacy, model privacy, testing data privacy, and output privacy. Output should be seen by client only with his private key. So there may be some attacks like poison attack, evasion attack, member inference attack, model inference attack. Poison attack is nothing but they will add some data records, so that they will poison the training data set, so that they will build a wrong model. So to deal with all these things, we have to use homomorphic encryption. So these are the things we are going to deal. So we'll use defense using homomorphic encryption. I'll explain some results of my work here. This is very easier to implement. We have to take data sets B005. So while implementing a machine learning model, we have to do it. We have to do it in we have to do it in different data sets, because to get generalizability, so B005, B006, B007, and B0018. So for that, we have to use two things. For predictions, for building neural network, we have to use TensorFlow, and for providing homomorphic encryption, for integrating homomorphic encryption, for encrypting, we have to use Tensy libraries. If you have any doubts, you can contact me. I'll give code on that, because time is very tight schedule we are having, so that it is very difficult now. So we can use all these libraries to implement, but rather than implementing a thing, already GitHub link is also here. I will share this PPT with you all through your coordinator. So first we have to get a good quality SCI publication. We have to find out a novel methodology that should apply in a new area, not like healthcare or finance. If you can work in electrical vehicles, you will have better chance. So that is about this. So CKKS is fully homomorphic encryption. You can use CKKS to encrypt. So Tensile, built on Microsoft Seal with focus on tensor and PyTorch style operations. So these are all CKK supporting libraries. So we have to see, we can see in GitHub. I'll send these links to you. You can easily see all those things. But we have to build a new methodology or novel things is very, very important here. So what are the challenges with homomorphic encryption? So computation overheads with encryption and maintaining prediction accuracy and handling diverse large data sets and interoperability across systems. In the latter half, in the last 20 minutes, I want to go with blockchain. There I will explain what is interoperability, because through blockchain also we can provide trust, security and privacy. We will discuss that. I will give a wonderful case study later. So this is about neural network and with homomorphic encryption. So if you use both, we can have wonderful thing. After that, we are providing privacy with homomorphic encryption itself. But what is the need of blockchain technology? Why we can integrate blockchain? If you can integrate blockchain to this structure, we will have greater weight. So because blockchain is nothing but it is distributed or decentralized or immutable ledger. It is very, very interesting. Listen carefully. I'll try to make it very clear to you all. So let us assume why blockchain. See, we are working in centralized systems. That means we will work on only one system or one cloud server. So there what happens? If that server fails, if the single node fails, entire system collapses. Instead of using only centralized database, we will use decentralized. Instead of one database, blockchain is not at all typical. It is very easier. Listen carefully. See, instead of one database, we will take 3 or 4 nodes. There we can have decentralized fashion. So that is one database tool, and that means instead of one node, we will take 4 or 5 nodes. So the same copy will be there in all the nodes. The same copy will be there in all the nodes. And whenever a new transaction comes into place, that should be added to this blockchain in blockwise fashion. So what is a block? Block is nothing but if you take some 10 transactions, if you want to make a block, we'll make a block after 10 transactions. Next, from 11 onwards, 11 to 20, we'll make another block. We'll make all the blocks into a chain. So that is nothing but blockchain. So this blockchain nodes will be there in 4 or 5 nodes. That means same copy will be there in all the 4 nodes. So that if one system fails, we can get the data from other. Is it clear? So single point failure is not there with blockchain. That's why we can go with blockchain. So why combine FHE with blockchain? That's I'm going to tell here. So blockchain ensures trust, but trust won't be given with machine learning or FHE. So trust will be given by blockchain, and accountability also there. If there is any misleading thing done, that can be traced using blockchain. So this is very, very important for blockchain. So nowadays the blockchain is trending and buzzing, so that if you focus on blockchain based systems, we will have wonderful chance of getting good publications. So first I want to explain about blockchain. I already tried to explain blockchain. I will try it more. So blockchain is nothing but it is a peer-to-peer distributed ledger technology for new generation applications. So funding is also very high for blockchain. Let us see. I'll show here. See this. So we are having, this is a distributed ledger. The same copy will be there in many places. Same copy will be there in many places. If some new transaction is added, that should be added in all the copies, so that we will maintain same copy in all the places. If one system fails, we can take it from other place, so that blockchain will resolve single point failure, and this is a shared ledger. Everyone share it to each other. But here, while adding a transaction to all, but it should all should agree, because we should not add a misleading data to the data set. All should, when more than 50%, 51, more than 50% are okay, then only the transaction will be added and the block will be added to the blockchain. So that is regarding blockchain. So, and the blockchain, why it is blockchain? Because the blocks are connected as a chain fashion. So that's why this is called as blockchain. Actually, we won't store data on blockchain because blockchain has limitations in regard to storage. So we'll store address on blockchain nodes. We'll store address on blockchain node, and the corresponding data will be stored in lake. The corresponding data will be stored in lake. Whenever we require store lake or cloud, so whenever we require a data, the data address can be taken from blockchain and we'll retrieve the corresponding data from the data lake. I'll explain later. See here. So now I want to explain healthcare blockchain. Now I want to explain about healthcare blockchain. So this in the healthcare perception, see here, we'll have doctor, prescriptions, MRI, biosensors, blood pressure, lab results, health monitor. These are all data collection things. So a doctor may collect all these data and they will make electronic medical record for each of the patient, and they will store these electrical medical records in encrypted fashion on data lake, and the corresponding address in encrypted form in the blockchain. Whenever somebody needs some data, it will be fetched through blockchain address from data lake or cloud. I'll explain a scenario here. Blockchain is nothing but, it is a very simple concept. As we register for an app, we'll register for blockchain also. In blockchain, patients will register, doctors will register, hospitals will register. So certain patient will register for certain hospital and a particular doctor. And let us assume a scenario. Your father is there in India. You are in US. He is aged. He is above 70. So, but he is alone. So that we have to take care of him. Then we'll register your father on blockchain healthcare, and you yourself register and to a hospital nearby to you or your family doctor. So we'll register for a doctor. So, and we'll give a healthcare quote to your father using sensors. I'll show in the next stage. So through that sensor data, we can collect his BP, his sugar, or something, some oxygen levels like that. If there is any abnormality happen, then the message will be shared with only family doctor who you have registered with, so that the doctor immediately through a smart contract, I will explain. Whenever some abnormality will be done, the smart contract will trigger automatically and he will send a message to the particular doctor. There he can visualize the vitals of the patient, and by seeing vitals of the patient, BP, sugar and oxygen levels, he can he can give suggestion from there itself, and he can save the patient. And if that is the not, if this is the not, if this is not the case, then the patient has to go to hospital. It is very difficult in that case. If time is very important there, within seconds the life will be collapsed, so that the blockchain will save a patient in this fashion. I'll explain very clearly in coming slides. Actually, the medical records will be stored in data lake or cloud, and the corresponding addresses only stored on blockchain, so that we'll get the data from data lake by fetching the addresses. See, here also you can see same structure. So we can collect the data, and after encrypted form, we'll put the data and addresses on corresponding blockchain. Whenever a abnormality happens, the corresponding data can access the data through the address on the blockchain from fetched from data lake, and they will visualize the data, and based on that visualization, he can suggest some treatment from there itself, or he can suggest some medication from there itself, or he can send some specialist doctor to the place to save the patient. So 1 minute, wait. To save the patient. So this is healthcare blockchain. See, this is also structure here. We will collect the data and we'll store the indexes on blockchain and the data on data lake. And whenever it is required, we can take and we can analyze the data, and we can integrate machine learning also here, healthcare analytics, and we can give predictions to the patients. Also. See, this is also healthcare blockchain. And see here, blockchain based on open source software. So we can easily implement this. See, I'll explain use case of blockchain in healthcare. Blockchain has a potential to substantially impact healthcare industry and as a whole, and payers provide and patient with respect to drug traceability and clinical trials and research and management. I'll explain a wonderful project to you all. See, we're having blockchain can provide secure structure, and patient data management will be done by the blockchain, and blockchain can manage healthcare records. So what is smart contract? Create a system of smart contracts for a rule-based method for access. Smart contract is nothing but a software program that can trigger based on certain conditions. Certain conditions are rules. I already explained. If BP is above 250, if sugar is above 300, it will automatically trigger, and the respective doctor will see all those things, and he will provide the respective treatment to the patient. So that is about blockchain data management. I'll getting into the project. 1 minute, wait. See, first the motivation we'll see why this system is needed, because we can see 2022 2050 the aged people are raising because many people are going abroad and their parents are alone and they are aged. We have to take care of them. We have to take care of their health, so that we need a blockchain system like this. So that is the main intention we are going to build a smart, secure, reliable, cost-effective healthcare system. Why it is smart? Because we will use sensors and everything. So, and we are providing privacy, we are providing predictions, and we will save time. And we are providing privacy so that it is secure and it is reliable. Reliable because blockchain provides trust, and it is cost effective healthcare system we are going to build. See, actually, if you see breaches, what do you mean by data breach? So day by day, there is increase in healthcare data breaches. You can see in all data breaches, 44% are healthcare data breaches only. So that much importance is there for providing privacy in healthcare. And in centralized systems, lack of reliability is there, lack of availability is there, lack of privacy is there, lack of security is there, lack of interoperability is there. If there is a problem arises, if a doctor is not available, that is a problem. But we are providing availability through blockchain. Automatically, the doctor will connect, and he can treat the patient. He can treat the patient so that it is reliable, and it will provide privacy, security, and interoperability. I will explain interoperability in the later. Later, I will explain interoperability. And mainly to save massive loss of time and money, eventually life. So we can lose a life within seconds. So if you provide treatment connected through blockchain from there itself, then we can save a life. We can save a life by suggesting something from there itself. So for that, we are providing blockchain integrated, decentralized, and secure smart healthcare system. We are providing. See what are the benefits of this. So mainly the system is for elderly and disabled because they cannot go to hospital. It is very difficult to take them to hospital. If time not permits, if the time is less, we can eventually lose a life. So that we have to build this type of models, because in the blockchain also what we will do is we will make longitudinal data of elderly. We will make their addresses on blockchain. Whenever some abnormality happens, then automatically the doctor may send ambulance or some specialist doctor to specific place where the longitudinal, by using longitudinal data. And product service providers for elderly, with the elderly families and caregivers. And I already told, so your father is there at India, you are at US, then you can take care of your father by using this blockchain system. So through smart contract, if there is an abnormality happens, then rule-based triggering will be done. And automatically the message will be given to the respective doctor, and that doctor will treat the patient immediately. Through mobile, they will give suggestions, or they can send nearby doctors or ambulance, and they will take care of the patients. So that is the use of this. This slide is wonderful. Listen to this. This can give clear picture what a blockchain is, what is the need of a blockchain. Let us take centralized system. Existing solutions are centralized systems. Proposed solution is nothing but decentralized, that is blockchain. So in the proposed system, we need to trust intermediary. Let us take hospital. We have to trust hospital, because if the doctor is not available there, a patient may die in a emergent situation. So availability will not be there. But here in the proposed solution, automatically the abnormality, if abnormality happens, the corresponding doctor will definitely see the message directly, so that availability will be there. And her son is also looking into it, and he can make some arrangements to his father. Okay, so that the first difference is here, this is centralized, this is decentralized. Second, cost per transaction is very high, as lot of intermediaries involved. Because if you take a bank, there are many employees, but if you see Bitcoin, there is no need of any employee. So this is Bitcoin, like this is like this. So there is no need of hospital, there is no need of making many doctors, so on, so on, so on. Okay, so this is reduction of transaction cost due to disintermediation. There is no need of going to hospital. We can only consult, or we can give access of your medical health record to your family doctor. He can see your data and he can treat you from there itself. No standard method for patient identity, but here we will use public keys and private keys, so that some identity will be there. No healthcare data interoperability here. Here there is interoperability. What do you mean by interoperability? I already explained, but I said I'll explain very clearly in the next steps. Let us assume a situation. Some parent is there, some son and his parent is there, and there are some abnormalities for his patient, for his parent, and the parent is registered with some doctor, but the doctor is unable to treat him because he has not that much ability to save the life, because every person will have some capability. Above that capability they cannot work, but to treat this patient, this doctor has to consult other doctor, so that he will send some data records to other doctor. But if the data record is in uniform format, that means it should be understandable by anybody. There is no need of doing tests again. So that if it is in uniform format, a standard format, if the data is sent to other doctor, he can visualize the position of the patient and he can treat, because he can easily understand, because this is in same format. That is called interoperability. It should be operated anywhere. That is called interoperability. And next is here limited access to health data, but because here this is distributed, there are many nodes, so that we will have wonderful distributed ledger. The access should be high, and there is no rules or permissions here, but here through smart contract we will give permission or access to specific persons only. So that is called privacy. We cannot open your health records to all the people. Only will share the data with specific doctors only. Fine. Specific doctors only. See here. I'll give the structure here. See, I already told. If your parent is there at somewhere distant from you, then we can give a code to him by using these sensors. The code may be built with these sensors, and the old person will wear the coat, and through that code the data will be collected, and through secure channel it will be stored on a cloud, and corresponding address will be stored on blockchain, like this. See, in this blockchain we are having three types. See, the lower tier is data acquisition layer. So there we will collect all electronic medical data records, and after collecting all electronic medical records, these will be stored on this cloud, EMR. The cloud is here in data storage layer, and the corresponding address will be stored on this consortium blockchain. Consortium means a group of networker matter, why people build a blockchain built by group of people. So that is called consortium blockchain. Corresponding address will be stored on this, and after that And after that, what happens is the hospital company, these people will require this data. So whenever a person gives access through smart contract, then only the top layer people can get information from the second layer. So if a patient gives permission to specific doctor, he can get the address from blockchain, and corresponding data can be taken from blockchain, from cloud and given to the doctor. In a similar fashion, whoever have access, they can only get the data. They can only get the data. So that is about this blockchain. That is about this blockchain. It will take 5 to 10 minutes. I'll close after 5 to 10 minutes. Listen very carefully. This is very, very important. So here there are 3 layers. One is data acquisition layer, and other is data storage layer, and the upper layer is data sharing layer. There we can share our data to a specific person, who may be a doctor, who may be a researcher, who may be a government, whoever wants data. If that is permitted, then only we can give the data to the hospital or company or government or researcher. So this is the blockchain structure we are having. And after this immutability, this is very, very important property. Why the blockchain will give trust? See, here nth block is there, n+1 block is here. Here see the header hash from n-1. So n-1 block header hash will be here, and nth block header hash will be here. So header hash of from block n value will be here. So if there is any change in block n, if you apply hash, and if you check with hash of block n+1, if there is any change, that means some modification will be done on nth block. We can identify, because this hash value is 123, and now if some change will be there, if you apply a hash on that, it will become 124. So 123 is not equal to 124. So that there is some change on nth block. So that what happens? So the trust is there in blockchain. Okay, we can identify if there is change or modification done anywhere. We can trace that. So that is the advantage of blockchain. So this blockchain will give anonymity, confidentiality, content extraction signature, and also improved privacy. So confidentiality and integrity will be given. I already told. Confidentiality means the data will be given to only persons who will have access, who will have permissions, and authentication, integration, and privacy is also there. And data sharing is also given through smart contracts. If a patient will give his data to his respective doctor only, he won't give to any other person. He won't give to any other person. He won't give the data to any other person. See, so the entire workflow is like this. The elderly and disabled patient healthcare sensor data will be sent to the doctor. The doctor will prepare EMR, electronic medical record, and electronic medical record will be stored in encrypted form on blockchain, not on cloud, and the corresponding address will be stored in blockchain. And if there is any access or abnormality happens, then the access will be given to specific doctor. Based on that only it will be used. So blockchain use case in healthcare is very, very important. We'll have various references also here. So in this session, we have seen how we can provide privacy to electrical vehicle SOH prediction. After that, what is the advantage of adding blockchain to that privacy preserving systems? And we have seen blockchain healthcare system. So this is very much useful to you if you want to work in privacy with machine learning, so that we will get wonderful SCI papers. I have more than 50 SCI publications, because of the novel things and novel ideas. But we can have, if you have novel ideas or novel things, first we have to make the methodology very clear. After that, you will getting into implementation is not at all typical. You can do it very easily. Rather than implementation, first we have to find the methodology clear. After that, after implementing, then implementation, presenting the results is also very, very important. We have to see various dimensions so that we will get wonderful, wonderful research papers. So I am very much thankful to you all for patient listening. If you have any queries, I can make it clear. Anybody can ask, or I will give my contact and mail address to you all. If you have any questions or queries, you can contact me, because it is 9:05 now. Okay, anybody, if you have queries, you can ask.
So participants, can you please ask your any queries or any doubts?
Or in first session or second session?
Yes, sir. So both the sessions we are ready for that.
So my suggestion is make this area privacy preserving. And if you integrate this privacy preserving machine learning with blockchain, you can have wonderful works so that you can get good research publications and reputation. If you have any queries or if you have any doubts, you can contact. I'll share my number to your coordinator and also mail. Okay. Thank
Professor,
you
one
very much.
chatbot, one question received, Professor. What is the focus on future aspect based that blockchain? So next blockchain importance of the society impacts.
Okay, fine. Because the blockchain is a decentralized system. Wherever you need decentralization, we can go for blockchain. Because if you take healthcare, if the data is stored in single database, there is, if the system is down, entire system will be collapsed. But if you can make it decentralized, we can have wonderful. In healthcare, we'll have wonderful chances in blockchain. And also we can make group key agreements and communication also through blockchain. Through communication also we can have blockchain. We can use blockchain.
Professor, one more doubt they are saying, Professor, the federated learning using the signal processing.
Fine.
How? Yes, sir, that one. How federated learning using the signal processing?
Okay, fine. So federated learning is nothing but a collaborative learning. So if you take signal processing in various clients, and if you can collaborate those parameters to build a global signal processing model, then that is nothing but federated learning. So that means the federated learning is nothing but don't believe one person. If you can combine the results of various clients, you can get better things. Anybody? Any other question? Federated learning is also a wonderful area you can work with. And there we are sending, I already explained, sending parameters directly to the cloud so that if anybody gets the parameters, then they can build the global model. So that if you integrate homomorphic encryption there, we'll have better privacy.
Professor, that another one, Ms. Nidina Afrin is asked that, sir, which area we can use for that research, especially for this kind of domains? Your suggestions.
Which area? You already I said various applications. You can go with smart grids. You can go with energy predictions. You can go with agriculture predictions. like that. So select a new thing, new area, because many people worked in healthcare, many people worked in finance. So that if you choose a new area, then you can have better chance of publishing.
Okay. So anybody else?
Sir, please
Yes.
share my contact or email also to them.
Already done, sir. So,
Ah.
okay, again, we can go further, sir. No problem, sir.
Fine, fine.
So, thank you for that valuable speech, sir. So, we have to get some insights. So, based upon that, it will be there. So, is necessary for that future coming is like AI with healthcare. That is like future. So, we will get much more impact. So, thank you, sir. So, thank you all of you. The first session will be is going to be happen by very limited participant. So, second session completely solved. It won't be happen again. So any problem in kindly please make a chat or anything. So thank you all of you. So thank you, sir. Thank you very much, sir.
Thank you, thank you. I'm leaving.
Yes, sir. So thank you, participants. We will meet again for tomorrow, the same time, 6 p.m. So the link, everything I will be shared to you. Who is the presenter, everything.